Thank you. Everyone can hear me, obviously. Oh, right, clicker, that would be helpful. If I fall over, it's not a big deal. I just forgot to breathe while talking. Okay, so I am Michael Thoreson, CEO of KRATE and co-founder with my wife, husband and wife team, sort of third venture together. And I'm here to talk about self-sovereign data, specifically the self-sovereign data storage marketplace that we are creating at KRATE. Interesting quote from Edward Snowden: privacy is not about something to hide, privacy is about something to protect. And those are who you are, or that's who you are, that's what you believe in, that's who you want to become. Privacy is the right to the self, and privacy is what gives you the ability to share with the world who you are on your own terms. Why did I start KRATE? Well, we all have been hearing about the various data breaches happening in many countries around the world. What is not always obvious is the economic impact. Roughly 2.6 million euro is lost due to cybercrime and fraud throughout the world. There's an illusion of privacy, which I will touch on later, and identity theft, which is something is not fun to go through. My identity has been stolen as a result of data breaches, and it can make things very complicated. This is the illusion of privacy. So when you hear them, most data storage providers say, upload your data unencrypted so we can store it more efficiently. As you've heard from Facebook with their data analytics problem, what they're really saying is give us your raw data so we can learn about you. When they say that we protect your data, can't always believe that, because 4% of all data breaches, only 4% of that data that was breached was encrypted. They say that you can control access to your data. Really, you can only control it to a certain extent. You can't always keep the storage provider out of your data. And they also say that your data cannot be retrieved after deletion. This is not always the case either, because delete operations are actually very expensive for a provider. And it's only irretrievable after it's been overwritten by other data. We believe the problem to be largely centralization. So the central storage of data is just attractive to data thieves or hackers, just like the centralization of cash in banks was attractive to bank robbers for a long time. The third-party trust requirement is also a problem. Doesn't matter who you store with. In a traditional setting, you have to trust someone with your data. That trust has been obviously violated a number of times over and over again. Just before coming here, I read an article that 9 million Canadians have been affected by data breaches in the last 8 months, over roughly 884 data breaches. So every 2 days, every day there are 2 data breaches affecting Canadians and their personal information. That is staggering. The other problem is improper implementation of data protection. There have been a number of articles where a data breach was not because of a clever hacker finding a way through someone's security. There have been many instances where the hacker was able to get the data through a web browser, and the information was just open and in the clear. Or a classic one is someone uploaded some of their code to GitHub, and in there was the credentials for their Amazon S3 bucket, giving everyone access to private information. Our solution, decentralization, and removing the trust component, because our platform operates without trust being a requirement, and with it being a decentralized distributed service, no central body has control or storage of the data. And our implementation will be peer tested and reviewed. We do have MOUs in place with University of Saskatchewan and Saskatchewan Polytechnic back in Canada, where we're from, to help develop and review the code, and as well the code will be open source and peer reviewable by anyone in the public domain. Now the system sounds like it would be complicated to use. It's not. As you can see here, just simply drag and drop your photos into the folder, goes up onto the KRATE network. And in the background is where the magic happens. This is a picture of Miss, one of our, what we call our fur babies, one of our cats back home. So we take the file, in this case an image, and we shard it up into a bunch of little pieces for easy storage. Then we run it through a compression, again to make it smaller. Then we apply a checksum to those pieces. This is important because we also build a table for data deduplication. If a file has information in it that is common in multiple files, we use deduplication to make the data that's uploaded even less. We just add a local reference to the data and minimize your bandwidth usage. Then we encrypt those pieces using just standard AES, accepted everywhere. And this is the, if you will, the secret sauce of the solution of how you can store private data in the public domain and ensure that it is protected and secure. We shard each of those encrypted pieces again, and the reason this is important is if you break up a piece of data that has been encrypted, even if you have the keys and the tools in order to decrypt that data, it's mathematically impossible unless you have all of the pieces that were part of the first shard. Then there's a second step of encryption in here for those the ultra paranoid. It's optional, not required. And there are some out there. Then we run this through erasure encoding. Most storage platforms that are not even just blockchain based, but also conventional storage systems, replicate the data and copy it into more than one place. This is highly inefficient, so we apply erasure encoding, which adds parity data that allows the data to survive multiple failures, but it doesn't have to be a specific part of your data that fails. Anything can go missing that is not in excess of the parity data. So for example, let's say these pieces, you have 100 pieces of data, you add say 30% to your erasure encoding for parity data, that now is 130 pieces that you then, in the next step here, oh sorry, we're not there yet. So you distribute those 130 pieces across our network. That means any 30 out of that 130 can be lost and you can still recover and reconstruct your data. Now, we add another checksum here which allows us to be able to view, or sorry, to verify the data has not been tampered with, has not been corrupted after distribution. So then here, the distribution shows that we obviously can go across a global distribution as the network grows, which is hugely beneficial for companies that are currently paying for a content delivery network or for an outside disaster recovery package or scenario. By the very design, our solution includes the properties of CDN and disaster recovery because of the potential of global distribution. We, however, do understand that some organizations have a requirement to define where their data is stored, and we will be rolling that out in a later version so that data sensitive data can stay within a geographical region should your legal requirements require that. So in short here, we have our feature being decentralized and distributed, zero trust requirement, zero knowledge storage, and self-healing, which I'll touch on now. With the zero knowledge storage aspect, the network can repair itself without having to know what the data is. So we don't need to know if it's health record or education material or anything like that. And the network can repair the data without your intervention. Benefits we have are the content delivery network. Participants don't need to trust each other. They don't connect to each other directly. Our masternode network routes the data internally so that the nodes don't find each other, helps prevent DDoS attacks. Monitor again without knowing contents, no user interaction to maintain data. Our first use case, I'll just kind of breeze through here, is going to be healthcare for Global Healthcare Connections, a medical tourism company. And it will allow you to manage messages and files, also who has access to your medical records and various files. track appointments, and this is important for medical tourism, as right now they don't have a solution for managing health data in a secure fashion. The pilot will prove that our process can work cross-border, cross-discipline, work with ancillary services like travel, hotel, car rental, while maintaining privacy and adhere to legislation. An advantage over other blockchain solutions are that we can fully incentivize storage providers to bring the storage to the network and stay on the network so our capacity doesn't fluctuate. Self-healing, which I've already touched on. Everything is user-centric, as it's your data, and we want you to be able to use it as freely as you wish. In the future, we do have a plan for a zero-knowledge proof of identity, which would allow people to prove their identity to further strengthen our access controls without having to reveal their identity. So anyone could validate someone's identity claim on the blockchain with a zero-knowledge proof without any exposure there. We also have plans for a proof of distributed compute. I can't say who at this moment, but we did find someone at this conference who is very interested in filling that gap for us in a future partnership. Summary: built-in content delivery network, disaster recovery, compliance, self-healing, fully incentivized. Also, we are platform and language agnostic. We're using .NET standards for our technology and for our smart contracts, which allow them to work with, again, any .NET standard compliant application or device. So we are highly interoperable and easy to integrate into existing systems, allowing transition over to KRATE for a full solution much easier. We like to say it's your digital data, your digital identity, and your digital life. You deserve to worry less and store more. And that's everything. Thank you.
Thank you very much, Michael. Are there any questions for Michael?
Yes.
Yeah.
Go ahead. Yeah.
Hi, thank you for your presentation. I missed the part where KRATE is saying that we don't track any of your records. We don't know where they are.
Okay. We don't have anything to
track. Yeah. Can you please explain more why KRATE is not monitoring all these places that your data are stored?
Okay. So the storage providers, it's a public permissionless blockchain that anyone can join and participate in. The storage providers then are also can be anybody. It could be anyone in this room providing storage to the network, and anybody can be consuming that data as a node as well. And the reason we can't track anything is because we don't store anything. We're not the ones providing the physical storage. We're just developing the software to create the network for anyone to participate in. An analogy would be Berkeley's distributed compute project, like Folding at Home, SETI at Home, that kind of stuff. Where people can donate. In the case of Berkeley, you donate spare computing cycles for research purposes. We're taking that idea and applying it to storage, but in this case, instead of donating, you actually can earn from the providing the storage to the network, which then other people consume and using the permissions that you set on your data. Does that answer your question? Okay. Any other
questions?
I have one.
Okay, sure.
Well, have you ever tested the throughput of your network? How fast is how many transactions can?
If we say transactions per second, are you saying like data transactions or currency transactions?
Well, data transactions. Okay.
The data transactions is difficult to test because it is going to be such a wide heterogeneous network. Ultimately the throughput would be an aggregate of the I/O between all the nodes that are in the network. There is nothing in our software inherently that would cause it to be a limiting factor. As with any distributed network, hopefully the capacity would be large enough that your individual connection would be the choke point and not the network itself. Okay.
Well, and about the transaction, the network transaction, The transaction for your network. What you mean? It's one, just one action, let's say, one interaction with the rest of the systems.
So if I was to download something from the network, I would want my own connection to be the bottleneck, not the network, and we achieve that by encouraging a wide distribution. So the total network is capable, its throughput and I/O would be the aggregate capacity of all the nodes participating in a distributed system. Does that help, or?
Yes.
Okay.
That helps.
Okay, thank you.
Well,
Thank you.
Okay. Thank you very much.